Yeah, I see I have to speed up because I was told 20 minutes and I saw it was 15 minutes here. So
it's fine.
Try to get through it. Since I'm actually living in what you define as the Arctic, my natural focus is to this area and challenges in this area. I'm working at a research institute owned by the University of Tromsø, and I'm heading the unmanned aircraft development research group there. And we have been doing research on unmanned aircraft since 2005, developing systems and services and doing environmental remote sensing using drones. When it comes to maritime security challenges, there's several phases of this. One is search and rescue, but also under the Arctic Council we have a group that's called Emergency Preparedness, Prevention and Response that address these issues and coordinates them among the Arctic nations. And important part here is also oil spill and situation awareness if there's been an accident offshore. It's not necessarily a search and rescue, but it could be, for example, a cruise ship in problems and similar. And then, of course, you have search and rescue, man overboard. In the North Sea, currently the rescue ships or supply ships that support the operations have a requirement of picking up people within 7 minutes. That's quite short time, and it's hard sometimes to find people in the sea when the waves are high. But also, if you look at who is interested in actually paying to develop services at sea, it's mainly oil and gas industry. For example, seismic exploration. There we have responsible of making sure there's no marine mammals in the area, that there are no small icebergs and larger icebergs, because when you tow a seismic array of 5 kilometers, you can't just turn and you can't stop because then it sinks. And you have ice management, as I'll show you later. Industry is moving into area with ice, and how do you tackle that? If you could extend your operational season with a week, you save millions, and maybe drone technology could do just that. And then, of course, also maintenance to get under and structures, look for places instead of hanging someone in a rope dancing around. You could send a small drone. It's safer and it's more efficient. Here are some scientific platforms that's been used in the Arctic and over ocean. They are not necessarily all suited for search and rescue. The smallest one here, operated by University of Bergen, weighs 500 grams, and it could fly for about 15 minutes or so, but it could climb to 10,000 feet. This larger one, the Russian Adi, flew on Svalbard, could fly for 1.5 hours, but still electric. And it also had both thermal and normal imaging sending back. Then you have the NOAA. It's also a small UAV, could fly for about 8 hours, petrol. And then the airplane we use could fly for about, this one, for about 8 hours, 800 kilometers. But we have also larger ones that could fly longer, like this Scan Eagle that's used by University of Alaska Fairbanks is used a lot on ships because it could land on ships and it could fly for 15 to 20 hours and a couple of thousand kilometers. And then you have the larger platforms like this one, weighed about 80 kilos. NASA had it up on Svalbard 3 years ago. And you have Global Hawk, which also have flown into the Arctic, and they're also planning to use it in oil spill exercises. And this one weighs about 16 tons, so it's largely larger than this one. And you could buy this one ready as a UAV for about 3,000 euros. You have to pay a little more for that. And also the amount of crew you need. From I heard operations with this one, they had well, total with scientists, everyone involved in operation was about 100 people. This one you could do with 2. So there's differences in cost, and usually I say the cost increases exponentially with size. And that's a good rule of thumb when it comes to unmanned aircraft. So when are drones a solution? Well, they have to be cost efficient, otherwise you could just use a manned aircraft or other ways. It has to be affordable, even if it's cost efficient for doing what it's supposed to do. If you can't afford to use it, it doesn't matter. It has to be safe. You can't put other people to an unacceptable risk, which means usually that you can't put people to more risk than you would do if you did it with a manned aircraft. And also you have to be able to operate in what you call bad weather. It's strange things, but accidents have a habit of happening when it's bad weather. So even if you have a high operations or availability, if you can't operate in the weather where the job is you're expected to do will happen, well, then you can't do anything. And you have to be good at the job. So you really have to bring some value to whoever is using this. So to achieve cost efficiency, one way is to actually have a system that addresses several challenges. As we heard earlier, someone wanted to combine the SAR and border surveillance. I don't think this is such a controversial combination of combining ability to look for man on board, but also detect oil spills and mapping these, and also, for example, inspect approaching vessels. If you have a modern ship radar, has a range about 48 nautical miles. You could see something approaching you. You don't know if that's the local rich person with this big yacht or if there's someone with some other intentions. And if you could see that early, you could then take measures like calling in support from Coast Guard or taking another course to avoid hitting or being taken by pirates. And also, when the northern sea routes now are opening, and also more and more fishing and such is happening up north in the ice, you need to detect and map the sea ice and icebergs where you navigate. And by doing that efficiently, you could avoid getting trapped in ice, and you could also save money compared to having to have an icebreaker to follow you. But you also have to require minimum of manpower, and if you are going to have these as a rescue platform or for something that's just happening, hopefully not very often, you can't have a dedicated crew, so you have to use the normal crew to operate. Once you have to have a dedicated crew with pilots, things cost a lot more, and you really have to use it efficiently most of the time for it to be cost efficient. So the system also must be highly automated and intuitive. If you want a crew to operate it that use it once or twice a year and they forgot it, it has to be like an iPad. You pull it up, you turn it on, and it kind of explains to you what you need to do. And also affordable hardware for use under even marginal conditions. So this is how we think it. You have a boat, you launch your aircraft from the boat, you have a screen, you draw a search pattern, the plane flies, sees something, you have an algorithm that automatically detects that spot and tells you the position, and you could steer then the man overboard boat straight there instead of having to search the whole area, and you'll save a lot of time. And time is critical. So, to be safe, conflict with other aircraft. A normal plane, you have a pilot looking out. You don't have that in these planes. So if you don't have a special permit or segregated airspace, it means line of sight. And that's actually something that is defined in some countries to 500 meters, some to 1,200, and some says it's as far as you can see without any artificial aids other than normal eyeglasses. So it has nothing to do with your 20/20 vision. Danger to the crew. Even a 3-kilogram aircraft, if it rams you at 100 kilometers per hour, it could cause some harm. But if you design it with soft front, for example, almost like an airbag, well, then you could solve that problem. The other way you could do it is to have the crew inside when you operate. Danger to the ship. If you fly one of these larger aircraft with gasoline on board and it hits the ship and the gasoline catch fire, well, you better have some systems to address that. So mitigations, you could extend this, for example, by using a ship radar and get that approved as your detect and avoid system. Suddenly you could fly out to maybe 40 nautical miles, which is a huge area compared to 1,200 meters. And also procedures keeping crew unexposed when you operate the aircraft, use aircraft of low impact energy, and avoid flammable fuels. You could go for heavy fuels instead of gasoline. It could be one way of doing that. And you have to be available. All aircraft have weather envelopes. It doesn't exist an aircraft that could operate in all weathers at all times. If you are in heavy clouds that are in sub-freezing temperatures, you can't stay in it for long because the icing is so rapid that even best icing systems can't really address that. And most UAVs don't have de-icing systems. I actually haven't heard about one having it once yet, but I know people are working on it. Aircraft have been the maximum depending on the design. Icing, but also visibility. When you come into land, you need to see the aircraft. So in fog, it could be a problem. And based on area, weather statistics, and purpose, in the Arctic, you have to care about icing. In the Mediterranean, not so big problem. You have to look at where you're going to use it. And also, you could design, for example, for 80 to 95% availability. So you have to look at the statistics for weathers, winds, and such for area you're going to put this, and then you design it. You don't need to over-design it to be as close to 100%, especially not if you're using it for something that doesn't require it. So, and you have to do the job. So, for example, if it's ice navigation, here you have a Norwegian icebreaker, testing how much force it is on the ship when it crosses ridges. So we have an aircraft going out there to measure the ridges and the volume of the ridges. And we landed on the deck. So SAR system levels at sea. We have, of course, national assets like rescue helicopters from certain stations on land, and we also have Coast Guard vessels. Challenge with these that it typically takes 45 minutes or more to get to areas. And if you fall in the water, at least in the Arctic, you don't live that long. You also have, at least in Norway, you have substantial industry assets. Because of all the oil platforms, there are rescue helicopters on those owned by the industry and also in Hammerfest. And they have also been used in other rescue missions. And also the supply ships and so on. So maybe in the North Sea you could get down to 25 minutes because you have a platform with a helicopter nearby. And you could have your own assets on board a boat. You have a man overboard boat usually, which you could put on the water to go and pick up people. But you could also have some small electric drones to help you find. Because the challenge often from boats is to find people in sea, especially when you have some waves. Usually you then don't see them for more than 50 to 100 meters from the ship, and outside that you can see them. And then, of course, you have drones, and they have cost, as I mentioned. You have the large drones. Usually when I say large, I mean over 150 kilos, so not that large necessarily. They could, the best systems today that are operational, up to 48 hours. But they're usually flying at a high altitude, so they could be used for reconnaissance and surveillance. But if you have clouds, you can't really use the large systems. You have to get down below, and then you have big challenges with the regulatory issues. And smaller drones, still high complexity, but lower acquisition and operating cost. So at least they are not more expensive than manned, but they still have limitations, especially when it comes to regulatory issues, but also communication. You can't send video from the Arctic Ocean because the only communication you have is a SATCOM that gives you about 2 kilobit. So it takes several minutes to transfer one image. And you have these micro drones, very low complexity, battery powered, low cost. The plane I showed you on the last picture is about 1,000 euros with the whole pilot and whole thing. But limited endurance, 1 to 2 hours. And still some regulatory challenges, as I mentioned. You could maybe get approval for using aircraft radar and such. And also it has to be worked in with the rescue centers, because you need to get these things away when the rescue helicopters comes. So there have to be clear ways of operating, and such are not in place. And talking about regulation, here is the roadmap that was presented last week from the European Commission. So as you see here, VFR stands for Visual Flight Rules. EFR stands for Instrumented Flight Rules. And then you have Beyond Line of Sight, Extended Line of Sight, and Visual Line of Sight. And you see, full regulation will be in place in 2028. So we have some time to discuss these privacy issues before we have to draw final conclusions, at least for the larger aircraft. But for example, the ship-based one I talked about could come already here. So here you see you already have some initial operations and could actually start almost today. But for the larger systems, you come up here, and that's not ready for use, at least not for a few years up. So ship-based SAR, this is kind of getting back to the DESSI. You have to set some requirement. You have to find people within a certain radius. You have to have real-time data. You have to be all-weather. For example, which we define in one project as 20 meters per second. It's not all weather, but it's a place to start. Easy to operate, train pilots and operators. And challenges is to get the platform robust, to get high bandwidth, regulatory requirements, and also automated detection and tracking. You could generate enormous amounts of data from these unmanned aircraft. Usually when I fly for scientific mission, we gather 13 gigabytes per hour. And it takes some time to look through that, so you have to find some way of doing that without the person being dead before you found him. And similar for oil spill response, you make a matrix, but you need some more range. And you could use that in real-time operations to steer the booms to collect oil most efficiently. So this is kind of trying to find what is the commonalities. Could we use the same platform for several usages? So you have to go through these for each of the usages you want to use. And then you have land-based search and rescue. If you go with large aircraft, you need a range of 500 to 1,000 kilometer radius. It has some challenges when it comes, especially robustness. Icing will be a much larger problem because you have to travel much further. You don't know how the conditions are. And also you need to have some new sensors to avoid collision with other aircraft. One is transponder with the so-called ADSB, which is things that make you send out your position every second or so. Maybe you need a radar to avoid hitting other aircraft. Also you need automatic detection and tracking, maybe process already on board. Since you have such low bandwidth, you can't send the images back, but maybe you could send the hotspots you have detected. And also, for example, drop the drift markers. If you have found something, you drop a sensor that will then report where it is, so you could follow the drift together with the other. Okay, so if you have a 2,000 kilometer range, which some of these small systems have, this shows you an example of a coverage area. This is Jan Mayen, a small Norwegian island. So you see, even with a few places of operation, you could cover huge areas. And also, last thing I'll talk about is actually supporting maritime operations. These are the places where there are oil leases and oil drill operations. It's a map from World Wildlife Foundation. So, and the light blue is the marginal ice zone where you have winter ice. The dark blue is the minimum ice extent in summer. And as you see, there's already a lot of operations in ice-infested waters. And today the technology is not there to detect and follow, for example, oil spills in ice-infested waters. And these are things that need to be in place before they could actually start really working in these areas. So They require new technology to maintain safe operations in these areas, and drones could possibly be part of it. You could also use manned aircraft. But the danger, for example, in some of these areas is to operate manned aircraft at low altitude has a certain risk also to the crew. And also, to be efficient, you have to start combination of satellites, forecasting models, and drones, and you have to make a system of the systems, basically, to do this efficiently. And ice management, if you have a drill rig up in an area where ice could come, you need to scout for ice in a 100-kilometer range. The reason is that ice drift speeds up to 25 kilometers per day is not uncommon, should even be quite a bit higher. So ice is coming in, and you need to know it, because if you want to decouple from the drill string, it takes 6 hours to do it properly. You could do it in half an hour, but then it will take you weeks to get it back on again, and that's a lot of time lost and a lot of costs. So that's why trawling companies look for solutions to do this remote sensing. And as I said on the previous slide, you need to combine then several assets, and maybe you could then save some money. And of course, as a scientist, what do we need? More R&D. As an operator, well, I need the regulations. I have something to, know what goals I have to meet. And as a user, well, you want a service, and you want it regularly. So you want a mature service and the product you need. And to succeed, all these have to work together. Otherwise, we don't get anywhere. And maybe DESSI could be a good way of using this process of getting this going. Okay, thank you.